Welcome to GE Reason Products Overview Training video. In this video, we'll be covering the following topics. We'll start with an introduction and a review of the history of Reason products. Next, we'll look at network solution and introduce the different features of S20 managed Ethernet switches, as well as H49 Red Box switch. For time synchronization, we'll look at RT430 and RT434 GNSS precision time clocks, as well as RT431 time code generator, RT411 time signal distributor, and RT412 optical transceiver. Last but not least, we'll look at measurement and digital fault recorders. We'll start with Process Interface Unit, PIU, the Integrated Analog and Digital Merging Unit, MU320, especially MU320E extended version. Next on the DR60 Compact Digital Fault Recorder, RPV311 digital recorder with PMU and TWFL, Phasor Measurement Unit, Traveling Wave-Based Fault Locator. And finally, we'll review what we learned in this training video. So let's get to it. Before we introduce the products of Reason, let's briefly review the history of Reason. In 1991, Reason Tecnologia was founded in Florianópolis, Brazil. In 1996, first DFR digital fault recorder model RP2 was manufactured. In 1998, GPS clock RT line was launched. In 2005, DFR new model RPV-310 was launched. In 2006, PMU Phasor Measurement Unit solution feature was added to the RPV-310. In 2008, the TWFL Traveling Wave Fault Locator feature was added to the RPV-310. In 2009, RPV-311 was launched as a distributed DFR with PMU. In 2013, the merging unit MU320 was launched. In the same year, the first Ethernet switch T1000 was jointly launched with Link Precision, consolidating its portfolio as a backbone of the digital substation. In 2014, Reason was acquired by Alstom Company, therefore became Alstom Reason. In 2015, Alstom Reason was acquired by GE, and Alstom Reason became GE Reason. The current GE Reason products portfolio covering network solutions from PRP to HST, time synchronization from Eric B to PTP 1588 V2, and merging unit from REAL to PIU, DFR with PMU and TWFL, born with the IEC 61850 spirit. Reason products are the Reason DEC for the modern digital substation. GE Reason Network Solution provide IEC 61850 network capability, adding more flexibility, reliability, and robustness for the interconnection of IEDs and the precision for synchronization. In this session, we'll introduce the S20 series Ethernet switches and H49 Red Box switch. The Reason Ethernet switch, especially from the hardware version C, are specially designed to operate in substation environments complying with most demanding safety standards: CE marked UL 60950-1, IEC 60255-27, and IEC 60110-1. Our robust design handles harsh environment with a natural fanless cooling system which complies with industrial standards IEC 668-2, which refers to extreme temperature tests from -40 to 85 Celsius degrees, IEC 60-255-21, which refers to mechanical vibration, shock, and seismic tests, IEEE 1613, the standard test requirements for IEDs in the substation, and lastly, IEC 61850-3 Edition 2. The user can choose the second redundant power supply option to increase the reliability. S20 is both a Layer 2 and Layer 3 managed Ethernet switch. As a Layer 2 switch, S20 dynamically routes the traffic between its individual physical ports according to the MAC address of connected devices. Using the Layer 3 capability, S20 expands on this by utilizing IP address information to make routing decisions when managing traffic between LANs such as intranets. The key benefits of a Layer 3 switch are performance from a hardware device, reduction of broadcast traffic, simplified security management, improved network fault isolation. When the S20 is operating as a router, IP traffic is routed between all internal VLANs without any further configuration. S20 will recognize all IP addresses from VLANs and route the IP traffic internally when necessary. Static IP routing, RIP, Routing Information Protocol, and OSPF, Open Shortest Path First, are available in this mode, and they can be used to route the traffic externally to routers or gateways. The optional Layer 3 functions may be upgraded via a licensing file, make it unnecessary to return the switch to the factory. The S20 switch enables the device to deliver full cybersecurity features that help operator to comply with NERC CIP guideline and regulations by supporting core features such as password complexity and encryption. The factory default password is different for each manufactured device, and after the first login, users must change the password with at least 8 characters, including lower uppercase alphabets, numeric, and special non-alphabet characters. Passwords are encrypted using SHA 256 and by default. S20 support REDIUS and TAC-X for the remote authentication, authorization, and accounting AAA technology. Role-based access control RBAC for local authentication of multiple users. Security events, logging local and centralized events via syslog. Secure communication using standard protocol SSH, SFTP, and HTTPS. To perform a secure firmware update, S20 used the checksum algorithm to check firmware integrity and a digital signature to ensure its authentication. The spanning tree protocol STP is defined by IEEE 802-1D and is used to identify the loops in the network. This protocol defines the route of the tree switches and the bridges. Only one path is available and transmits the network data. In the case of failure in any link between two Ethernet switches, the STP protocol recalculates the best path once again, and after a short period of time, the communication is re-established. In addition, the IEC 61850-90-4 technical report specifies the Rapid Spanning Tree Protocol, RSTP, when looped topology, such as the ring topology, are required at the station level of substation networks. With Ultra RSTP, Ryzen S20 achieves fault recovering time with less than 5 milliseconds per hop, reducing packets loss while maintaining the interoperability with other standard RSTP devices, thereby meeting the IEC 61850-90-4 specifications. Ryzen S20 supports Ultra RSTP natively. No extra configuration other than the standard RSTP is needed. Bridge Protocol Data Unit (BPDU) guards and filter to prevent external interference in spanning tree networks. Ryzen S20 complies with IEEE 1588 v2 Precision Time Protocol and can operate either as transparent clock or boundary clock to ensure time accuracy for PTP-aware IEDs in the network. The PTP license also allows upgrading the functions in the field without returning the device to the factory. Ryzen S20 can also operate as an NTP server, translating to NTP client devices connected to an S20 using an Ethernet switch as a source of time instead of using the GPS clock. The switch time source can be IEEE 1588 v2 by converting PTP to NTP, another NTP server, or manually entry. The real-time clock RTC via its supercapacitor can maintain activity for 2 days after the S20 is powered off. Simple Network Management Protocol (SNMP) is widely used in network management systems to monitor network-attached devices for conditions that warrant administrative attention. SNMP exposes management data in the form of variables on the managed system, which describe the system configuration. These variables can then be queried or sometimes set by managing applications. The latest S20 brings configuration file upload-download using SNMP, SFTP, firmware update using SNMP, SFTP, and enable-disable extra interface protocols using SNMP. Using IPMC and IP multicast filters, a group of receivers in the LAN may be configured to receive the data from a sender. Without multicast filtering, multicast messages are sent as broadcast messages. When it comes to power system communication, IGMP protocol can be used when there is multicast communication between a phasor measurement unit PMU and a phasor data concentrator PDC. With IGMP snooping, the receiver can send a joint group command to join an IP multicast group. Ryzen S20 supports IGMP V1, V2, and V3 protocols. S20 use USB or Ethernet ports with a web browser interface for configuration, monitoring, and firmware upgrade. The Ryzen S20 series has two models, S2020 and S2024. S2020 is a cost-effective choice, offering a high density of Ethernet ports in a 1U form factor for easy rack mounting. The model supports up to 5 modules with 4 ports each and allows configuration with up to 20 fast Ethernet ports and up to 4 gigabit ports plus 16 fast Ethernet ports. S2024, the premier model, offers 4 gigabit Ethernet switch functionality. This model supports up to 24 ports provided by 6 interface modules with 4 ports each. The 1U mechanical design is identical to the S2020 model. In both S2020 and S2024 models, Layer 3 functions and IEEE 1588 v2 PTP on all ports, hardware-based, can be upgraded via a license file. The reason H49 Redundancy Box or Red Box is GE's all-in-one gigabit redundancy solution. It has been especially designed for the digital substation for use on the substation bus and process bus. In a mix of PRP dual star and HSR high availability seamless redundancy rings, the gigabit HSR ring allows the transport of multiple sample values streamed on the same ring, simplifying the network topology. Why do we need a red box? A device with only one port, such as a printer or computer, is called a singly attached node, SAM. It is a node with non-redundant network adapter. A SAM can communicate with other SANs and DANs, doubly attached nodes running PRP, on the same LAN. When a SAN is attached to a redundant LAN by a redundant Red Box device, the SAN can communicate with all the other DAN and other SANs in both LANs. In other words, if a redundancy of a SAN is required, the SAN is connected to both LANs through a red box. Reason H49 product is manufactured in Montpellier, France, and is the first DNV GL fully certified PRP HSR IEEE 1588 IEC 61850-3 device in the world. H49 has these key benefits: all-in-one PRP and HSR Red Box, HSR Quad Box, and PRP HSR Coupling Box. Multiple features to reduce the number of devices: Quad Box, 4 SAM ports, port modularity, up to 4 SAM ports to conduct PRP HSR non-compliant devices to the redundant network, reducing the number of red boxes. 3 available SAM ports, which used as PRP HSR coupling box. IEEE 1588 v2 boundary clock and transparent clock capable to distribute precision time across the substation network and PRP HSR boundaries, saving the cost of cabling used to deliver IRIC-based signals. Supports simplified network management protocol SNMP v3 with full backwards compatibility for the V1 and V2. Simple but powerful web management interface for all configuration functions like those used in S20 switch. Dual power supply for the increased reliability, and Achilles ACC Level 1 certified, designed for NERC CIP compliance. The Reason RT platform provides the time solution across a power grid, synchronizing protection and control devices from traditional IRIC-B to the latest IEEE 1588 PTP timing. In this section, we'll cover these topics: Reason RT430, 434 GNSS precision time clock, Reason RT431 GPS precision time clock, Reason RT411 time signal distributor, and Reason RT412 optical transceiver. Global Navigation Satellite System GNSS incorporates American GPS, Global Position System, Russian GLONASS, Galileo of EU, and Beidou of China satellite system. RT430 and RT434 GNSS clock now tracks the GPS and GLONASS satellites simultaneously. and whenever one constellation is lost or reports bad quality, the clock will continue running in full synchronization based on the healthy resources with zero switch over time. GPS plus GLONASS allows the receiver to be pinpointed by a group of 48 satellites all across the globe. Using both satellites together increases accuracy and coverage. GNSS constellations combining prevents attack from GPS jamming and spoofing. The front panel of RT430, RT434 comprises an LCD display, 2 indicators, and buttons to navigate through the screen. By navigating through the display using the buttons, it is possible to check the configuration of the equipment's Ethernet network, IP addresses, network mask, gateway, broadcast, and DNS server shown for each network. Both clocks support NTP, PTP 1588 V2, PPS, PPM, and IRIG-B outputs. 3 PTP profiles available: PTP power profile C37-238-2011 and 2017, and IEC 61850-9-3 PTP profile for power utility automation. IEEE C37-238-2017 and IEC 61850-9-3 are completely compatible and can work together without restriction on the same network by setting its domain number. Although C37-238-2011 was superseded by the other standards, it is still available for the legacy network and may compatible depends on the IEEE 1588 V2 network configuration. RT clocks use a web browser interface for monitoring and configuration in 5 languages: English, French, Spanish, Russian, and Portuguese. RT430, RT434 GNSS features a TCXO as its standard internal oscillator, ensuring free-running accuracy when the clock is not locked. RT430 and RT434 has the optional second redundant power supply with AC-DC high voltage or DC low voltage options. The RT430 has 2 Ethernet ports and optional PRP functions, while RT434 has 4 Ethernet ports without PRP function. Choose the RT430 in the Ethernet application where IEC 62439 PRP redundant architecture are required. Choose the RT434 where 3 or 4 electrical network ports are required. Scenarios where using the PTP in a PRP network is required are rapidly increasing, as these 2 protocols meet all the benefits and economical viability of using Ethernet communication network to interconnect intelligent electronic devices, IEDs, inside the substation control house. It is indeed possible to achieve full redundancy with zero-time recovery when put PTP and PRP protocols together. The RT431 timecode generator is a compact GPS-based clock designed to be installed in a DIN rail that supports electrical DC level shift time signal, serial datagram, network time protocol NTP, simple network time protocol SNTP, and IEEE 1588 V2 precision time protocol PTP. When configured as PTP ordinary clock, slave, RT431 also works as a transceiver from PTP to IRIC-B serial or pulse time codes, enabling the use of PTP on legacy IEDs that do not support this protocol. Here, you can pause the video to see the feature comparison of 3 clocks RT430, RT431, and RT434. The reason RT411 time signal distributor is a cost-effective way to synchronize multiple devices in the substation. It works as a time signal transceiver providing up to 20 time outputs from a single input, such that expense of installing multiple GPS antennas in the substation is avoided. Typically, the RT411 is installed as a port multiplier, acting as a slave to time signals received from a GPS clock. There are 2 types of DC level shift time sync inputs: optical with ST connector or TTL electrical with Euro type connector, which can be selected by a jumper. For the 20 DCLS time sync outputs, there are 10 optical ST connectors, 8 Euro type electrical, and 2 BNC connectors. RT412 optical transceiver is an electrical-optical or optical-electrical time synchronization format converter whose characteristics allows multiplication of GPS clock outputs and distribution of time synchronization across the substation where there are significant distances between the panels. It converts a twisted pair electrical input to ST optical fiber output, or conversely, it converts an optical input to an electrical output. It has one optical input or TTL electrical input, one optical input and 2 electrical outputs. DIN rail mounting, same as RT431. In this section of measurement and digital fault recorders, we'll cover these products: MU320 Process Interface Unit, DR60 Compact Digital Fault Recorders, RPV311 Digital Fault Recorders with PMU Phasor Measurement Unit and TWFL Traveling Wave Fault Locator. As we learned in the IEC 61850-102 module, the process bus is intended to replace the hardwares between the ITs and the IEDs. There are 3 basic types of devices that publish data for process bus: merging units MU, remote I/O modules RIO, and Process Interface Unit PIU. RIO publishes equipment status in Goose message. Merging units convert AC current and voltage signals in the substation yard to the digital sampled values with a timestamp. A PIU, like Reason MU320, is a bridge between the physical and the digital world, publishing both analog status data in both sampled values and Goose messages and subscribing Goose to control outputs. It is IEC 61850-9-2LE compliance, offers interoperability with other process bus devices, with no reliance on proprietary technique. It aims to reduce copper cabling and trench dimensions in the substation yard thanks to its fiber optical data transmission. There are 2 models of MU320 in the market now: a regular MU320 or standard MU320 and MU320E, extended version of MU320. Standard MU320 has 2 slots, for current, voltage analog inputs, and 2 slots for digital inputs and outputs. The number and function of the slots are fixed. MU320E has 2 extra slots for digital inputs and outputs. There are 2 flexible I/O slots that can be configured as analog, current, voltage, or binary inputs. There's a maximum of 6 I/O slots that can be configured, allowing up to 96 binary inputs and up to 48 binary outputs. MU320E can be configured as a merging unit, remote I/O device, or PIU. MU320E has 2 serial ports for maintenance. A new P5 option has Form C contact outputs. The digital input's voltage threshold is configurable, and there are extra logic nodes for modeling like control of circuit breaker, XCBR, and switchgear, XSWI, and for self-monitoring, LCCH, LTMS, and LGOS, etc. MU320 has 2 independent sample values IEC 61850-9-2LE streams, measurement of 256 samples per cycle, or protection 80 samples per cycle profiles. MU320 was tested and approved by global testing and certification company TÜV-SÜD according to the implementation guideline for digital interface to instrument transformers. It can be synchronized with either IRIG-B or IEEE 1588 PTP. There is optional PRP function for network redundancy. Goose messages can be in simulation mode, and possible configuration mode are test, test block, off, and on. Alarm LEDs turns to orange color when MU320 is in the test or test block mode. After rebooting, the MU320 will remain in the test mode. MU320 support functionally constrained data FCD for Goose, subscriber, publisher, and MMS TCP/IP report control block. Other features are up to 6 cards for digital inputs, allowing up to 96 BI and up to 48 BOs as remote I/O devices. For MU320E, they are high-speed, high-brick output contact with the operating time being less than 0.2 millisecond. The binary outputs are configurable to be pulse, pickup, dropout, and latch. The MU320 is a compact size to fit 19-inch rack mount installation, suitable to be placed in cabinets and kiosks in the yard. The weight of MU320 is less than 3.5 kg. DR60 is a natively IEC 61850 concentrated one-box multifunction digital fault recorder DFR and synchrophasor measurement unit PMU. The waveform recorder is supporting 256 and 512 samples per cycle, can be used as a disturbance and continuous disturbance recorder, trend recorder, and sequence of events recorder. All DR60 files, including configuration and logs, are stored in a non-volatile SSD memory. The device removes the oldest records as soon as the mass storage occupation reaches 80%. Born with IEC 61850 spirit, all the DR60 internal functions are implemented and mapped according to IEC 61850 Edition 2 logic nodes and data models. Even its configuration is performed using the native SCL files. It features MMS report control blocks for communication with supervisory system and Goose publisher and subscriber for interaction with other IEDs through the IEC 61850 process bus. There are serial and Ethernet interface ports with the time synchronized through IRIG-B or PTP v2. The DR60 provide a powerful and cost-effective synchrophasor measurement solutions according to IEEE C37.118 2011 to 2014 standards and is capable of transmitting synchrophasor in up to 4 separate data streams. Each stream can be configured independently based on contents, frame rate, performance class P or M, and communication modules TCP or UDP. Disturbance record can be configured to record continuously or be triggered by a Boolean equation, by a cross-trigger signal of other recorder, by a manual trigger using a web interface, or by triggering of the fault recorder. Configurable Boolean equation logics can be created and associated not only for triggering records but also to binary outputs, being used as alarm or simple automation in some applications. Like MU320E, DR60 has 2 binary I/O slots and 4 flexible I/O slots, which can be configured with up to 32 analog channels, up to 32 transducer inputs, up to 96 binary inputs, and up to 48 binary outputs. The primary function that can be selected in the order code are waveform recorder, disturbance recorder, continuous disturbance recorder, trend recorder, and phasor measurement unit. The reason RPV311 digital recorder with PMU and TWFL works as a distributed DFR, which needs remote acquisition units like RA33X. As a DFR, it can record waveform, disturbance, and continuous disturbance, SOE, and trend, same as the DR60. The RPV311 can also measure the flicker and harmonics for the power quality. For the communication, RPV311 is only the subscriber for Goose and sample values. It can transmit the data to SCADA via Modbus or DMP3 protocols. Unlike DR60 can be time synchronized with IRIG-B and PTP. RPV311 can be synchronized with IRIG-B and NTP or SNTP. IRIG-B is mandatory for the PMU and TWFL. NTP, SNTP are only for fault recording and other non-time critical features. With up to 64 analog 256 digital inputs and up to 320 Goose inputs per processing unit, the whole plant or substation information can be saved into one single device. With over 30 GB of solid-state internal memory, the RPV311 can keep the data for years without the need for external storage devices. For the remote acquisition modules RA33X series, the RA331 has up to 8 analog inputs channels, up to 32 digital inputs channels. RA332 has up to 16 analog inputs channels and up to 32 digital input channels. RA333 has 3 traveling wave inputs, up to 8 analog inputs channels and up to 32 digital input channels. The RPV311 can also be used for PMU measurement with remote acquisition modules according to IEEE C37.118 2011-2014 standards like the DR60. Here are some differences with DR60. RPV311 has 4 multiplex streams. DR60 has 4 independent streams. RPV311 has a frame rate of 10, 12, 15, 20, 30, 50, 60, and the DR60 has only 50 and 60. For the communication, RPV311 has UDP only, and DR60 has both UDP and TCP. The precision class for RPV311 is M class only, and for DR60 it has M and P classes. And lastly, RPV311 has WMU, waveform measurement unit, for sub-synchronous oscillation monitoring, while DR60 lacks this feature. The reason RPV311 TWFL solution is composed of RPV311 process unit, RA333 high frequency acquisition unit, and RT43X GNSS clock. The highly reliable fault locating system uses an innovative and patented combination of traveling wave and fault detecting algorithm. The typical accuracy can be within 150 meters regardless of line length. Precision is not affected by line and fault impedance. Mutual coupling effects load all compensation circuits like the capacitor bank, so it can be used for various fault locations: high impedance, HVDC, zero compensation, and hybrid line, etc. The RPV311 records high-frequency traveling wave. The data is then processed by the DR Manager software, which automatically downloads the records, calculates the fault locating, and makes it available with a Modbus for SCADA communication. Maintenance crew are thus directed to the exact location of the fault without need to resort to vehicle, helicopter, or foot patrol to find exact location. Worldwide, there are over 550 lines that have installed RPV311 travel wave fault locator as of 2020. Now let's recap what we learned in this video. We started with the history of Reason and all its products. Next, we introduced different Reason products from network solutions using S20 and H49 Red Box. After that, we covered the difference between the S2020 with S2024 on numbers of ports and speed of the ports. Moving on, we look at the exceptional Reason products H49 Red Box, which is manufactured in Montpellier, France. And then we introduce the time synchronization products from RT43X GNSS clock to the RT411 time signal distributor and RT412 optical transceiver. We explained the difference between the RT43X series and especially the difference between the RT430 and RT434. The first one has 2 Ethernet ports but with PRP option, and the second one has 4 Ethernet ports without PRP option. And finally, we introduce measurement and digital fault recorders, which includes MU320, DR60, RPV311. By this point, it should be clear what a merging unit is, what are real remote input-output device, and what is a PIU, process interface unit. MU320 can be configured into any one of these devices depending on the order code. At this point, you should be clear on the difference between a standard MU320 and MU320E, extended version in both hardware and software. For the DFR products, DR60 and RPV311, we introduced their common features, including the PMU measurement and their differences. The main difference is that one is concentrated and another one is distributed DFR. with Remote Acquisition Units, RA33X. Lastly, we introduced TWFL function of RPV311 with an accuracy of 150 meters. There are over 550 of these products already installed worldwide. We have covered all this in this overview video of our recent products. As a resource, you can always go to GE Grid Solutions website to download the brochures for each product to get more detailed information and parameters. In the future, we'll gradually publish specific product training videos for the following training related to Reason. Reason 101 S20 switch, Reason 102 RT430 clock, Reason 103 MU320 PIU, Reason 104 DR60 DFR and PMU, Reason 105 RPV311 PMU and TWFL, Reason 106 H49 Red Box. We'll also publish various how-to videos and as a quick help resource. For example, how to upgrade the firmware of the products, how to update the license, how to set up the VLAN and mirrored ports in the S20 Ethernet switch, and how to set up the power profile and utility profile in RT430 with GE IEDs. This concludes this Reason overview training video, Reason 100. Thanks for watching and good luck with your studies.